Got it.
I guess I should share screen. Share the whole thing. All right. So this is DRAT, and we're going to talk today about HTTP. Who wants to, without going to Wikipedia, summarize what they think HTTP is?
I didn't know this was going to be interactive. This is.
Oh yeah, it's definitely interactive.
This is a joke.
I guess it's a protocol for exchanging information between a server and a client with just text.
Yeah, that's not bad.
You can get, and you can post, and you can put, and you can delete.
And you can options.
And you can options. Yeah, that's not bad. I think that it's another way to describe it is that it's a protocol for a client to a stateless protocol for clients to request a resource and have the server return a response with that resource. And so it's a sort of request response protocol, which is distinct from some other protocols, which are, where the client and, well, where there's multiple clients and their peers. So there's lots of different kinds of protocols. HTTP is just one. It typically, although it doesn't have to, sits on top of the TCP IP networking stack. You could make HTTP requests to your neighbor if you liked, and they could fulfill them with a printout and send it back. But typically this is over a network. And I think, like Mika said, it's a text-based protocol. So the framing around the information that's being exchanged is text. Of course, you can transfer binary data over as, in the sort of body of those requests and responses, but the actual framing of those requests and responses is text. So what makes up an HTTP request? Well, the request and response are actually pretty similar. So, I mean, example, HTTP request. This is a bad example. Here we go. So, this is what a typical HTTP request looks like. There's three parts to every request. There's a request line, which is a single line of text, which contains information about what the requester is looking for. There are a set of headers, which are used for all kinds of things. They're pretty freeform. They're extensible, basically, colon delimited key value pairs on subsequent lines. And then there's optionally a body. So the body is arbitrary data. That's pretty much what a request looks like. A response is actually very similar. I wonder if it's on the next page. So a response has a status line. It has a set of a set of headers, and then again, a body, an optional body following that. So we can look at this in a little more detail. but this is a little Python server that I wrote. This thing basically it is now typically the way that an HTTP server runs is that there is a socket that's listening for incoming connections. That socket accepts some kind of accepts a client connection, and then there's a reading and writing process that happens there on that connected socket. Sockets are going to be a topic for another day, but basically sockets are the operating system level primitive for typically TCP and UDP communication between computers. So what this server does is pretty straightforward. First it creates a socket, binds it to a port, and then listens on that port. Can you all see this? Is this big enough?
Yep.
Yeah.
And then what it's going to do is it's going to call this socket.accept function, which is basically an operating system call that's going to block until, typically it's going to block until there is a connection established by a client. At that point, you have another socket object. So this client object here is actually another socket, and as well as the address of the connecting client. And that's what allows the response to be sent to the right place. So the client, again, is just a socket. Sockets have a small set of operations that you can perform on them. The most common are send, receive, and close. So you can see this whole loop here. The client receives bytes. There's two places where it's receiving a single byte, and then it is processing or is parsing the request. Once the request is parsed, it's going to send data back to the the remote party via this send all is it's actually sort of a slightly higher level primitive. Send and receive are very low level primitives, and they're kind of a pain to work with. Send all is slightly easier to work with, but basically it's sending a response. We can see it here, the status line, the headers, and the body. So this is a working HTTP server. If we do curl on it, we'll see a get. We'll see curl will print out. This is the body of the response. So I've actually echoed the headers back as the body of the response, just so we can see what's going on here. You can see that curl included a handful of headers by default. And you're all probably familiar with user agent is a common one. Host is an interesting one, because I believe in the original, back in the day, host used to help, and still does, differentiate multiple servers on the same physical machine. So I can, the client is actually sending a host header saying, this is who I am sending information to. And the server can then, if there's multiple servers, actual server processes running on the same machine, then it can differentiate and send it to the correct process. So this is a weird sort of thing on top, or convention on top of HTTP, that helps sort of routing. Except this basically just means the MIME types that we're willing to accept. There's a whole bunch of shit about like what, you know, proper HTTP response, what you're supposed to do in the event that, you know, you can't return the proper resource of the requested type. It's many pages long, but for a very simple HTTP server, you know, you can and actually in a lot of cases, in real HTTP servers, you just kind of return whatever's at a particular path. So that's the response. This is what this is the request headers being echoed back at us. This is the server printing out what the request looked like. So you can see that this is the request line of the request. It's the first line of text. And if we put a different path here, you can see that the path on the URL is actually part of the request line. So the request line is basically the client telling the server, hey, I want to execute this verb on this path using this protocol. That's essentially what it's doing. It's the server's job then to do all the internal routing, you know, to the correct handler, you know, with and you know, returning the right responses if the you know, if the document can't be found and so on. But this is the essence of HTTP. So if we actually you know, open our browser and we look at this, you can see, actually, let me open one without cookies. So you can see it's echoing back the request headers, and you can see the browser included a lot more headers. So again, it's got that host, it's got that user agent, which in this case is much more complicated. And it's got, you know, the sort of things it's willing to accept. But it's also got, you know, the language that, you know, the client has set, the encoding, encodings that it supports, do not track. I guess I have do not track set somewhere. And a few other things. So all of these things are layers on top of HTTP. So like the very core protocol is super simple, and most, like a lot of what sort of the complexity of the protocol comes from the conventions in the headers, you know, that get passed back and forth between in the request and response. So just looking through the request parser here. This is a simple state machine, and basically because HTTP does not specify the size of the request or the response up front, the actual parsers end up being a little bit more complicated. They kind of have to process a byte at a time, because you don't know when the HTTP, when the server is reading a request, it does not know when is the end of the request. Many other protocols, like most binary protocols, for example, will have upfront a length of some kind of frame that contains the body of the you know, whatever the packet of information that's being transferred is. But because this is as text protocol, we actually have to kind of process it character by character. So you can see basically, if walking through this a little bit, if the state is if we call put put character and the state is already done, we're just going to barf. If otherwise, we are going to call some underscore put C method based on the state. So the first sort of state that it's in is the request line. So it's going to read the request line, and only when it hits a new line character is it going to be done with that state, and it's going to, I mean, assuming everything is formatted correctly, it's going to set the state to headers, and it's going to clear the buffer that it's been reading into and parse the request line as UTF-8. I'm actually not sure. I think it might actually need to be ASCII, so this probably is not correct. We're decoding it as UTF-8. We're reading bytes, and then we're interpreting those bytes as UTF-8. And if it doesn't look like we expect it, then it's going to barf. Otherwise, we're just going to put the character, if we're still in the request line, we're just going to put the character into our buffer. Just going to do that again and again and again until it hits a new line, and then it's going to know that's the end of the request line. Okay, now we're reading headers. So then we're doing the same thing with headers. We're reading line by line, and it's only when we encounter an empty line that we know we're done the headers. So that's just the HTTP protocol is like, there's a single line that's the request line, and then headers, 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 and then there's a blank line. And that's how you know you've hit the body. One of those headers, one of the important ones, is this content length header. So if we have a body that we're passing to the server, what that usually means, so we're going to do a post here. What that typically means is that you need to set a content length header so that you know how long the body is. If there is no content length header, this is a weird thing about HTTP. If there is no content length header, it may mean one of two things. There is no body, the body's empty, or it could mean that it's an old client. I think maybe HTTP 1.0, where at the end of the request, it's just going to disconnect. Or at the end of the response, it's just going to disconnect the client, and basically it establishes a new connection for every single HTTP request that it's going to make, and it would know it's done reading the body when the disconnect happens. So more recent protocols, HTTP 1.1, I think, and 2, you have to have a content length header to be able to include a body. Although what I found when I was writing this is like, it's actually pretty permissive still. So like, there's like definitely backward compatibility weirdness that goes on with clients and servers. Content length, we're going to take note of and basically store that. And then once we are, we're not at a carriage return, we're going to actually either set the state to body if there is a content length, or to done if there is no content length. One other thing to note about this is that something that I now forget, so we'll move on. So once we are reading the body, basically, if there is no content length, we're just going to throw up. We shouldn't get there, but otherwise, we're basically going to read until we have got the content length that we're looking for, and then we're going to set the state to done. And that's going to tell the caller of this function that, hey, we're done parsing. So you can see it's basically checking this. Put C returns Boolean, indicating whether it's done reading. So that's a basic HTTP parser. What else to say about this? This is a single, this server is very basic. All it does is read a single, it accepts a single connection, services that connection, and then goes back to accepting. So that means that if a request takes a long time and another request comes in, it's going to either block or it's going to deny the connection or something along those lines, depending on how you have your socket set up. So this is not a good HTTP server, but it is an HTTP server. At the end, we close the connection. Actually, you can see it here, the way that the browser made its request. This was a request header, said keep alive, connection keep alive. So this is a more recent HTTP thing. Like I said, it used to be that a client would connect to a server, it would basically throw its request at the server, read the response, and then to get disconnected or disconnect. You may have in more modern HTTP protocols, you may have heard things like interleaving requests on a single HTTP connection. This is sort of a precursor to that. So the connection keep alive is just a way that basically a server and a client can reuse the same connection, because it turns out establishing the connection is relatively expensive. So for high performance, scenarios, you want to keep that connection open and then just have the client and server, ping pong their requests and responses. This is a request by the client to keep that connection open. My server does not respect that, but it would not be very hard to add that probably. If you did that, you would want to obviously, remove this restriction of only having one connection, one request processing at a time. And you would need to probably start threads for each open connection, and sort of that kind of processing. A lot of what most HTTP servers, what differentiates HTTP servers is sort of how they manage open connections, how they sort of listen for them. The naive implementations don't do a good job of reusing connections, or they're limited to a single thread for processing, or there's lots of different, or they fork a whole new process to service each request, or to service each connection. So there's lots of variations on how the server can actually manage connections and handle requests and responses. And if you see some server claiming to be high performance HTTP server, it usually means that there's it supports multiplexing on a single connection, and it has multiple, many worker threads doing request processing and those sorts of things. A lot of the old school HTTP servers were very dumb and inefficient. Nowadays, anything on any modern runtime is going to be pretty sophisticated in terms of those things. So that is HTTP, all about HTTP. Any questions or areas you want me to dig further in here? I'm happy to like edit code or go further.
What don't you like? The
What don't I like? Brussels sprouts. About HTTP?
Yeah.
Wait, you don't like Brussels sprouts?
I actually do like Brussels sprouts.
Yeah.
I thought you were gonna see people.
Well, there's some people I don't like. What do I like and not like about HTTP? I mean, that's a pretty hard question. I mean, I think that, what the like more recent iterations on the protocol show is that the initial protocol was not optimized for performance from the beginning. A lot of what amounts to like web performance issues have boiled down to HTTP issues. And so that's why you see a lot of like these new sort of extensions where they will like request multiple resources over a single HTTP connection in parallel so that the servers can fetch all the JavaScript and all the CSS at the same time, and things like that, because the original protocol was just this like ping pong thing. And so like if you have to do that dozens of times for every web page, then that's going to be slow. So at the time it was more than good enough. One interesting thing that I think is not actually I might let's see. What? No Telnet.
I like that it has afforded us all livelihoods.
It's true.
Yeah, that's a good call.
I don't know if
We are all HTTP engineers here.
Children of the HTTP.
Mm-hmm.
I'm gonna try this. How do you Telnet connect? Like I said, oh god, this is horrible. I just want to know. Okay, I think I can do it this way. Telnet localhost. Okay, so one interesting thing is like the Telnet command is a pretty cool it's like a raw TCP connection. So you can actually like more you can actually play around with the protocol more in a more interesting way. So like I can get whatever HTTP 1.1 and then I can go basically I manually entered the request, had an empty line to indicate the end of the request, and then it printed out the text response from my server. You can do this to Google. Actually, you can't do this to Google. You can do it you can't do it over TLS, but you could do it to like who has like an HTTP like what website is available on HTTP at this point? Like terrible,
not HTTPS,
like terrible real estate agent websites or something. Like
right.
You could like Telnet to open the connection, and then you can manually type in your HTTP request and headers and body if you wanted to, and you would get a response. The that's something that's actually really cool about the protocol, right? Like it's neat that like it's at the sort of bottom level, it's super basic. And I mean, I think that's why it was designed this way, was so that people could mess around with it and like, you know, debug things and figure things out. So that's like that's something that I do like about HTTP. What else?
I have a site if you still want to test it.
What? Nothing inappropriate.
No, it's just HTTP with LTS.
Uh-huh.
Throw it in.
Future form.
All right. Get. Boom. There's their webpage. Oh, bad request. I didn't like it. Let's see. What is their server? Apache. So Apache is probably, you know, noticing that like this is this request was junk because it didn't have like a user agent, or it didn't have like a host. Maybe actually, let's try host. Get on HTTP 1.1, and then let's do a host futureform.io. And let's see if that does any better. Ooh, no, it wanted, it probably, I don't know. I didn't like it though. Didn't respond. So it wasn't a complete request. From its
Tried
perspective.
example.com and it worked.
Example.com.
Yep. Dub. Or 80, yeah. Or just not dub.
Don't like it.
Weird. It's
So I don't know. Maybe it's available in France, but not here. So, you know, that's pretty cool. That's pretty cool that like HTTP is super, you know, at the end of the day, it's like a really simple and straightforward, easy to understand protocol. All the shit we layered on top of it, you know, I bet you the spec was 5 pages when it first was published, and now it's probably 500 pages. As everything, but you can still build an HTTP server in 100 lines of code, and you know, web browsers will still connect to it, which is pretty interesting. What else?
One painful thing is that, as you said, we still have to maintain compatibility with the older versions, so it makes it harder to create new versions that don't break that compatibility.
Yeah, totally. As a HTTP server author, I imagine that would be the fucking nightmare.
Yeah.
You know, it's also another interesting aspect of it is like we layered on TLS, right? Like HTTPS, but the protocol, the underlying protocol is the same, but now you're just establishing a different sort of lower level protocol to base the HTTP communication on top of. So at the end of the day, like HTTPS is, you know, what you are actually transmitting over HTTPS is just HTTP requests. But there's like another sort of protocol or variation of the protocol underneath it. So it's, you know, it's pretty flexible. We build apps on it now.
Is there anything like you're looking forward to in terms of potentially new things added to HTTP in the future?
No.
Or
Not really. I mean, maybe like like I said, you speed up some of these, like you keep these connections open and support multiplexing requests across them and stuff. All of that kind of stuff is supported in HTTP 2 now. There's not much. I mean, it's more like, it's one of those things where like you keep adding more features. It's like less is more. Like the more features you add on top of it, the more cruft, you know, ends up you end up having to deal with and stuff like that. Like I think keeping it very stable is probably wiser than trying to like cram more shit into it.
As far as I understand, HTTP 3, the changes in HTTP 3 are going to be at a level below applications, so it should be mostly transparent for those who don't want to change anything.
Mm-hmm.
I think there's a very good article around HTTP 3 on Smashing Magazine. I'll see if I can find it.
Cool. All right, everybody. So I guess that's all I got. And I will create a repo for this this code and check it out if you're interested in screwing around with HTTP. Thanks, y'all.
Thank you.
thanks, Dylan.